So latches, we do have some no change state by doing something like a feedback from output to input, from output to input. Okay. So this one called a latch, which is a type of temporary storage device. Temporary means we just put it there, waiting for so next command, and then we can remove it. Temporary means if we remove the power supply, all information will be released. Okay, will be removed. All right. So this one has two stable state. One is set, called set. One is called reset. Okay. All right. So set, reset, latch. Okay. We want to set means we make the Q to be high. We make the latch to be high. Then with reset, we make the output Q to be low. Okay. We reset the latch. Okay. So we need to produce some feedback, okay, from output to input. So these are two examples for the latches. This one called the active high input latch, means if set is high, output will be high. We set output to be high. So this one called the active low latch, just the opposite. So the set is low, output will be high. Just set output to be 1. Just some opposite way. All right. So this just some two examples to make latches. Now let's prove it really does work. We need to do some circuit analysis. Okay. So this is one type of active low set reset latch. So we can set output to be high or low by input, and we can keep output to be no change. Supposed to be no change. Now we want to test is really no change or not. Okay. So can you tell me these two circuits are same or not? Any ideas? Seems two different logic gates there. Okay. Any answers? They are same or not? Should be same. Okay. So actually, we already introduced in previous chapters. We change this is a NAND gate, right? NAND gate. We can change NAND gate to OR gate. Just push the bubble to the inputs, okay, and change the AND to OR. Actually, it's like the same. Okay, this bubble pushes there. We have two bubbles there, and then to OR gate. So actually, they are exactly the same. Okay, same circuit function. Okay. All right. Your textbook sometimes use this one to be convenient to do circuit analysis. Sometimes use this one. Okay. Let's do it. We use this one first. Okay, to do the circuit analysis to see if we do have a no change or not. Okay. What do we do? Let's think about this one first. Okay, let's start from this one. Here is 0. Okay. Here 0. This is a NAND gate. One internal input is 0. Output will be always high. Okay, it's NAND gate. And it doesn't matter the condition here. So output Q must be high. So we finish first one. So Q will be 1. Different color. Will be 1. Okay. And here is 1. Here is 1. And then this input is 1. So 1, 1 here should be 0. Okay. So this one we finished. Okay. So this, as we mentioned, if Q is high, we call the latch set. Okay. All right. So the first one finished. Let's think about this one. Okay, this one finished. How about this one? All right. Let's start from here. This input terminal is 0. Okay. Again, this is NAND gate. One terminal is 0. Output will be always high. So not Q is high. Okay. Very similar as the last case. So here is high 1, and another terminal is 1. So 1, 1. A NAND gate here will be 0. So this one is 0. Okay, make sense? All right. So as we mentioned, if Q is 0, we call the reset. So this one called the latch reset. Okay, we finished 2 conditions. All right. Now let's come to here, the first one. Okay, let's write down here. Here's 1. Here's 1. So here's 1. How about information here? So here is not Q, right? So here's not Q. So 1 NAND with not Q. Output should be Q. Okay, get my point? 1, let's say 1 and Q, not Q will be not Q. We have another not, will be no not, will be Q. Okay, which means no change. That's interesting. Initially it was Q, now it's no change, will be still the Q. Okay, let's think about this one. Here is Q, Q and 1 will be Q and not. So this one will be not Q. Okay, will be same. Okay, which means 2 output terminals are all no change, which means we can make a memory no change. Okay. Very similar with the previous case, the simple circuit. By feeding the output back to input using this particular circuit, we can find a condition. If Q to be high, information will be no change. Okay, let's say we change from this condition 0, 1 to 1, 1, and initially it was 1. Here will be 1 again, no change. Okay, depends on the previous condition. Okay. Okay, another one is a little bit tricky, 0, 0. Okay. Actually, 0, 0 is causing some problem. It's what we don't want to see. Okay. So let's see, if here is 0, doesn't matter the information here will be 1, right? If here is 0, okay, doesn't matter information here, output will be 1. So output should be always 1. Okay. So actually this is called invalid condition. So this is not what we want to see, but actually it exists in this circuit. So because the output supposed to be inverted with each other. One is high, one is low. One is low, one is high. But now it's always high. Both are high. So this is not good for our circuit application. That's why I call it invalid condition. So later we will introduce some more circuit arrangement to remove this condition. Okay, so make sure this condition never happens. All right, so this is latch operation.